Okay, dear students, let us start with chain type surveying. So today we will discuss about the basic principles of surveying. Basic principles of surveying. So there are two basic principles on which the whole of the survey is being carried out. The first principle is called as location of a point. Location of a point from two reference points. From two reference points. The second principle is called as working from whole to part. So these two are called the very basic principles of surveying. One is location of a point from two reference points which are permanently present in the site. And the second principle is called working from whole to part. So coming to the first principle, what is the importance of this particular principle of location of a point from two well-defined points? For example, I want to survey details for construction of the road. So I will be having a starting point, what is called as A. So you must refer this particular point from two well-defined points. Let us say a building is there on your drawings. So measure this particular distance as x and this particular distance as y. So x and y will be the known data for any particular surveyor. So I am representing this point A by means of measuring the distance of this from corner of the building 1 and corner of the building 2. So, and I want to continue my line. So I am going to measure the direction of the line, say A to B. So this one we call it as bearing of line. Because certainly we will be using either prismatic compass or surveyor's compass to note note the direction of a line. This is called bearing of line AB. See, now you may ask, what is the importance of this? Say, for example, we will be doing survey work today, and we are going to move along the line from A to B, and I am going to collect lot of data that is required for the design of the road, right? So now, if this work is to be taken up after 1 year, I want to go for construction of that line. So my values and survey the whole school only if I locate this point A very accurately. See, after going there, I know the distance x. So keeping one end of the tape, this point and excel the radius, I am going to draw an arc. And keeping the tape end here with y as distance, I am going to cut the previous one. So at any particular time, I can locate this point very accurately if I have the data that is x and y. So this particular process, we call it as location of a point from two well-defined points or points of reference. So now there are various methods. I want to locate the point A. Again, I consider the building corner, which is a permanent object present in the field. I can measure x and y, or I can measure one distance that is x and this particular angle can be measured as theta. So for this I am taking two data. One is x and another one the direction of this particular line from the corner. So I need two references, that is x and y, x and theta. Similarly, you can locate a point by means of knowing two directions. Say this is building corner and I want to locate this point A. I need not measure the distance. I can measure this angle as theta 1 by using a compass and this particular angle theta 2. So if theta 1 and theta 2 are known to me, I can locate this particular point A by means of measuring theta 1 and theta 2 by using a compass. So this particular method is called location of a point from two reference points, and this principle we call it as one of the first basic principle of survey. Now we'll come to the second basic principle, what is called working from whole to point. To get to survey a particular area. So let us say I want to collect all the details which are enclosed in this particular boundary. So let us say A to B is there, then B to C, C to D. See, the whole entire area enclosed between A, B, C, D, E, A is to be represented or surveyed. So now what we are going to do is, first, see, generally surveying of any particular area is done by means of dividing the area into number of triangles, because triangle is the basic figure which is very commonly used in survey, and this method is also called as triangulation. That is, the whole area is divided into number of triangles and moving our instruments along the length of the triangles, all the details such as buildings, hill, roads, etc. are going to be plotted on the plan. So now what we are going to do is, this is the area to be covered. I am going to select some stations. See, A, B, C, D, E are called as the main stations. Now, station means it is a prominent point in case of our survey work. So, I am going to establish the points as a whole, all these things in first plate. That is, I am going to establish A, B, C, D, E, and later on to connect various other data, I work from whole to point. Whole thing I have considered in a single step. First one, I have considered the area as a whole, and I am establishing the points A, B, C, D, E, and so on. Next is, you divide this into number of triangles, and you can move your instruments along these particular triangular lines, and you can locate the plan of the area. So this particular procedure, what we adopt in surveying, is called as working from whole to point. So as you want to establish all the entire main station points, select subsidiary station points and move your chain line or tape line, and you can locate the various data. Say, for example, a building is there. I can locate this particular building while moving along the line A to C. See, building can be located and its plan can be prepared. Similarly, let us say I have a road running here. So I can locate the number of points on a road passing through this particular area when I am moving along this line and along the line BC. So this particular procedure adopted for the survey body, we call it as working from whole to part. And you may ask, what is the importance of working from whole to part? See, when we are moving from one part to another part, if there is some error accumulated, error may be instrumental error or personal error or natural error. So, such errors can be eliminated there itself in the field. Because, as you know, when I move parentheses like this and from C to A, it has to close exactly if my survey work is correct. Otherwise, it will not close. There will be some closing error because of various mistakes. And that can be corrected if we are working from whole to why we need to work from whole to part. So these two we call them, and in your examination also this particular question is very commonly asked. Explain this with neat sketches as I have drawn on the board. Next we will go to the topic, that is measurement of horizontal distances. So once you know what are the basic principles of survey, the next thing is we will concentrate on measurement of horizontal distances. So there are various methods of measurement of horizontal distances. Measurement of horizontal distance. See, one of the main objects of studying about survey is we need to measure the horizontal and vertical distances in the field. So as to construct a particular project, either it may be a road or a dam or a bridge or any other structure. So for this we need to measure the horizontal and vertical distances. So now there are various methods which are very commonly adopted for measurement of horizontal distances. These methods are classified as below. One is direct method. Second one is called indirect method. Third is called electronic distance. Electronic distance measuring. This is also abbreviated by EDM. EDM. And fourth one is called total station method. So now we will take up each of these separately and discuss how exactly direct measurements are made. See, direct measurements means I can measure the distance, horizontal distance by means of using a chain or tape. The previous class I had shown you the chain. Today also we are going to discuss about the different types of chains that are available for use for measuring the horizontal distance. Then indirect method. Say, to calculate the horizontal distance, we can use some of the techniques. We can measure certain directions and certain lengths, and using trigonometric relations and various mathematical formulae, we can definitely determine the horizontal distance between the 2 points. So, we call some of the methods as direct because directly the field I will come to know. Immediately after using a chain or tape, I will measure the distance from one end of the line to the other end of the line, and I will come to know directly what is the distance from A to B. So directly we can measure. And there are some indirect methods, as I told you. We can use certain mathematical relations like Pythagoras theorem and trigonometric relations like sine of theta is equal to opposite side by hypotenuse. So like that, we have various formulas which we can adopt and we can determine the distance. Such methods we call them as indirect method. See, the third and fourth method, here, the basic principle of reflection of light, so is being adopted in electronic distance measuring instrument. So it is an instrument which is going to, see, I want to measure the distance between the 2 points in the field, A and B. So at B, hold a target. A target will be there for both the total station as well as electronic distance measuring the instrument. And here, over point A, set your theodolite. This theodolite is going to send a ray at some particular angle, and automatically it is going to measure the horizontal distance, that is AB. So directly in total station, and that is the main principle is it will go and hit the target and it will get reflected and it will come back to this particular total station or EDM. So these are the electronic instruments which are used nowadays very commonly to measure horizontal distance between 2 points in the field. Next, we will come to some of the direct methods. There are many direct methods which can be adopted. First one is called basic. Second one is called measurement using tachometer. Measurement using tachometer. Then third, measurement using pedometer. Then fourth is called measurement of horizontal distance using odometer or speedometer. Odometer or speedometer. See, we'll come to the direct method. First one, pacing. So the meaning of pacing is you walk from end A to end B, whose horizontal distance is to be measured. So you need to start from A and reach point B along a straight stretch. Count the number of paces. Pace means one step. One step, what you walk is called a pace. So count the number of paces. Later on, you walk 20 steps. Initially, you might have walked, say, from A to B, 1,200 steps, right? So now, accurately, gently, you walk 20 steps and measure that length covered by 20 steps. Measure that length. So, convert that. Take the average length of pace that you have covered. Let us say I am going to cover 60 centimeters in one step at an average. So now number of steps 1200 into distance covered in single step, that is 60 centimeter. If I do, I am going to get 720 meters as the distance from A to B. So this particular method is adopted. See, in our some we are having tape and various other more sophisticated instruments. So, where this particular method can be adopted? See, this particular method is adopted to fix the scale for your map preparation. Say, I am having a village. I want to survey all the details, roads of the village, houses, everything I want in the form of plan. What for? It may be for water supply project or it may be for improvement of the roads, parks and various other activities in the locality or it may be for drainage project. So I am requirement of map of that particular village. So, to what scale you are having a drawing sheet on which you are going to prepare the plan of that particular village. How do you fix the scale? Walk from one end of the village to the other end. Then along the width also you walk and measure these two distances. See, your drawing sheet size may be around 40 centimeter by 60 centimeter. So, to get that village plan within a single sheet, select along this direction, your drawing sheet is 40 centimeter, along this direction it may be 60 centimeter. So, considering width and length of the village to be covered, you can fix a very suitable scale. So, for this, we are not worried much about the accuracy. Approximately, we want the length and width of the village to be plotted on a drawing sheet. So, this basic method is adopted generally in case of reconnaissance survey to fix this scale for which a map has to be formed. Because if I blindly fix some scale, everything may come out of the sheet or some additional sheets may have to be added to that, which increase your work in the field. Therefore, to fix suitable scale, this basic method can be adopted. Measurement using gasometer. See, gasometer is an instrument which just resembles the watch, that is stop clock. So you get a stop clock. Mahatma Gandhi was using a stopwatch and he always used to tie it to his belt. So it is just like stopwatch, and this particular instrument can be kept in our pocket while walking. It automatically counts the number of steps because while walking from A to B, I may forget sometimes counting. I may go on counting the number of steps. So, to avoid this confusion, you keep this gasometer in your pocket and walk. It automatically counts the number of steps and number of steps multiplied by the average length covered in each of the steps will give you the horizontal distance between 2 points A and B. Next is called pedometer. It is a similar type of instrument, but it is an improved format of gasometer. Gasometer, it will only count the number of places or steps, but pedometer is not like that. You can fix in that the average distance covered by you in a single step. So it automatically counts the number of steps multiplied by the average distance that you cover in one step and directly from A to B. So you need not once again multiply number of steps and average length covered in each step. So it is an improvement of passion, odometer and speedometer. So all of you might have seen how the horizontal distance traveled by you is recorded in your bikes, cars, and other vehicles. So it is directly how many number of times the wheel has rotated, and the perimeter of that particular wheel is known to us. perimeter is not to us, it will directly multiply and it will give you the distance covered or distance moved by the vehicle. So, normally in case of vehicles, this odometer and speedometers are adopted. And also, in your hydraulics lab, to how many revolutions Pelton wheel turbine or other turbines are have rotated. This odometer we are going to use. So speedometer all of you see, when you come to fifth sem, odometer also it will given to you in your for counting the number of revolutions rotated by the turbine or pump like that, any instrument. So these four methods are generally they are coming under direct method. So as I told you, electronic, indirect, and along this, the fifth is called chain or tape survey. Chain or tape survey. See, generally, the above all four instruments, what you are going to use to measure the horizontal distance, they are not perfect or they are not accurate. So, to have still more accuracy in our measurement of horizontal distances and to use in all types of grounds. Say, for example, you cannot move the vehicle everywhere in a hill or hill or some other conditions. So, under such cases, the very best method of measuring the horizontal distance is chain and tape survey. So, chain is an instrument, tape is also an instrument used to measure the horizontal distances. So now we will come for the very basic concept, that is chain and tape survey. So before that, in the previous class already, I had shown you the various instruments that are used along with chain and tape for measuring the horizontal distance. So the first one is called chain, right? We will go in depth about the chain. Then second one is called tape. Third one, for the purpose of ranging, we are using ranging rods. And fourth one, wooden pegs. Wooden pegs. Fifth one, arrows. And sixth one is called blasters, laps, and weights. So these are some of the instruments which are very commonly used to measure the horizontal distance along with chain and tape. See, I have shown you in the previous class a chain. We have different types of chains which are used for measurement of horizontal distance. One is called metric chain. The first type of chain is called metric chain. Second is called Guntus chain. Third is called engineer's chain. Then fourth is called revenue chain, and fifth is called steel band chain. So now we will study the different types of chains. Metric chain. See, we have a metric chain here. I have shown you in the previous class the chain. See, this particular chain is called metric chain. And this particular chain are available in length of 5 meters, 10 meters, 50, 20, and 30 meters. See, here, length of each link from center of the central ring to the center of the next central ring. This particular length is 20 centimeters. So, for any metric chain, whether it is 5 meter total length, or 10 meter, or 20 meter, or 30 meter total length, it will consist of a link that is steel wire of 3 to 4 mm diameter, which is given this particular shape. So, this link is connected by means of using 3 number of rings. 3 rings, so that it can be rotated or folded above that particular heat. So it acts as a heat. So the least count of this particular chain is 20 centimeter or 0.2 meters. And at every 5 meter length, you find a brass leaf like this. So all of you can see the brass leaf. This indicates end of 5 meter. So in 1 meter length, how many links are going to be there? There will be 5 number of links. 5 into 0.2 will give you 1 meter length. So at the end of every 1 meter, you will find a small brass wire line. So that indicates end of 1 meter, 2 meter, 3 meter, 4 meter, and at 5th meter, this type of brass line will be there. And again, at 10 meters length, you will find at 5 meter length, the brass ring will be having this particular shape. Single leaf, right? At 10 meter, you find a leaf cut into 2 parts. And if it is 30 meter length tape, you will find at 15 meters this particular brass ring with 3 cuts or 3 leaves we cut. So this indicates 5 meter length, this indicates 10 meter, and this indicates 50. Again at 20 meter you find this type of brass leaf. Again at 25 you find single leaf. So this is how you need to recognize what is the length of measurement made by means of using a chain. And as I told you, these are available in 5 sizes: 5 meter, 10 meter, 15, 20, and 30 meter chain. These are all metric chains. Then coming to the next one, Guntur's chain. It is calibrated in FPS system, that is feet and inches. So this Guntur's chain will be 66 feet long. Total length of the Guntur's chain is 66 feet long, and it will consist of 100 number of links. How many links will be there? See, I will show you. This particular chain here, and also Guntur's chain, it is calibrated in feet with total length of 66 feet, and it consists of 100 number of links. So, what is the length of each link? 66 feet divided by 100. So, it will be 0.66 feet. Each link will be 0.66 feet. So, again, you may ask, because earlier during the British time, all the distances were measured in FPS system. that is furlong, mile, then area was measured in as acres. Nowadays, we measure that in a metric system as hectares. Hectares means 10,000 square meters. So, one of the main advantages of this is 10 Guntur stain, 10 square Guntur stain is equal to 1 acre of land. See, even nowadays also we measure land in acres. See, if you want to measure 1 acre of land, how many Guntur stains are required? 10 square. 10 square Guntur stain is equal to 1 acre. See, you spread 1 Guntur stain 66 feet like this and 10 times 10 into 66 feet. This area enclosed is called 1 acre. This is equal to 1 acre of land. So, even nowadays also we are measuring the area as so many acres. We are not using hectares as a common area measuring unit, still not. In practice, when you go to the public, they will tell 30 feet by 40 feet site is available, or 30 feet by 60 feet site, or 40 by 50 feet. So, still in public, this FPS system is being adopted. If you go to any revenue department, they tell you your land is 4 acres or 4.5 acres, like that. Therefore, to measure area of land in acres, this Guntur stain was very commonly adopted. Even till now, also this is used. Now let us come to engineer's chain. See, engineer's chain is having a length of 33 feet. See, if you imagine 66 feet length chain, how heavy will it be? So to reduce that weight of the chain, another chain was established. It is engineer's chain. And also, the one link of this engineer's chain, one link is equal to 1 feet length, it is rounded off. In this case, it is 0.66 feet, but in case of engineer's chain, it is of length 33 feet and one link is equal to 1 feet. Therefore, how many total links will be there? There will be 33 number of links which are joined by means of the links. Next one is revenue chain. So coming to the revenue chain, the total length of the revenue chain is equal to revenue chain is a little bit this one. Revenue chain is 33 feet in length with each link 2 feet to 1 by 16 to 1 by 16 feet. So, it consists of 33 links, revenue chain. Then steel band chain. Normally, to measure the waistlines, very accurately adopting all types of corrections for the waistline. Particularly, I told you about triangulation. We are using one of the methods, that is dividing the area to be surveyed into number of triangles and rotating. One of the line is taken as baseline. So, accuracy of your work mainly depends upon how accurately you measure this particular baseline. So that you are going to get a very precise plan by means of adopting this survey. So, to measure the baseline, we use a steel band chain. So a steel plant chain is going to be used. See, I'll show you the engineer's chain. Engineer's chain. It will be having a length of 1 feet. See, it is having length of 1 foot. And normally 33 links will be there in this particular chain. Next, we will go for the second type of instrument, what is called tape. Again, we have various types of tapes. The first type of tape is called, so we'll take up tapes, cloth or linen tape. Second is called metallic white tape. Third type of tape is called steel tape. Fourth type, depending upon the material, it is called inward tape. Okay, first I will come to the cloth or linen tape. This is the instrument. It is nothing but a tape which is made by means of cloth or cotton. So cotton fibers are used to make this particular type of tape. Generally, when you go to a tailor shop, tailor is going to take your measurements to stitch by means of using a tape, what is called cloth or linen tape. The disadvantage of this is the thermal coefficient of expansion of this material is very high. That is, if we apply more force, it will get extended. So, we cannot make use of this particular tape for very accurate measurements. So, an improved format of this has come, what is called metallic white tape. Here also, we commonly use a tape in our laboratories for measuring the horizontal distances, which is called metallic white tape. An improved format of cloth or linen tape. So, two metallic wires are reinforced inside the linen cloth or linen tape, and its thermal coefficient of expansion is lower than the first type, that is cloth or linen tape. So, if you want for applied measurement, you can use metallic white tape. Coming to steel tape, again here, it consists of entirely the steel material, normally with masons or with the supervisors. You are going to find this particular type of steel tape. So, it is still more accurate than the cloth or linen tape and metallic white tape. Inward tape is still an improved version of steel tape. It is an alloy of steel and nickel mixed in proportion of 70% steel and 30% nickel. So, its coefficient of thermal expansion is very, very low in comparison to the steel tape. So, for very, very accurate measurements of horizontal distances, we may use inward tape. Next, we will go for the ranging rods. Ranging rods, I have shown you in the previous class. It will be having a short shoe at the bottom, and it may be made up of either wood or steel, and it is painted by means of alternate layers. See, this layer is red, this is white, this is red, this is white. So like this, alternate color is being made, and this particular ranging rod is used for the purpose of rating a line. Because, see, if the length to be measured in the field is within one chain length or within one page length, definitely we can use stake, we can stretch it from one end to the other end and I can determine the distance. If it is greater than one chain length or chain length, I have to establish number of points in between the 2 points given at the end. So I need to establish 2 more points. How to establish? See, I am going to range. Range means from A to B. My measurement should be done in stretch from A to B. So what we do is, we are going to hold one rating rod here, another rating rod here. And then I lost my survey team, or 2 or 3 people, to hold the rating rod in line with this. But they are not in exact line. I will be standing at this particular point. This is my point. I align exactly in line with AB, and I lost this man to move and occupy this position exactly in line with AB. Similarly, I will direct the surveyor here to hold the rating rod exactly at this point. See, now I got some additional intermediate points. How will I got? By ranging. This we are going to discuss in next article in detail, various methods of ranging. So, once I establish number of points, I can stretch the chain exactly in a single straight line. Otherwise, what happens is, without this point, once you stretch your chain like this, another time like this, see what happens to the measured distance. It is going to be more than the actual distance. Therefore, these ranging rods are used for the purpose of ranging. They are alternately colored, white, red, white, and so on. And it will have a sharp shoot at the bottom. You can drive this ranging rod into the ground. If you want to fix a point, you can drive the ranging rod inside. That's why a sharp shoe is provided at the bottom of the ranging rod. And generally, our ranging rods are available in length of 2 meters, 3 meters, and 4 meters, and also 5 meters. See, normally when you are working in Gati, if you have only 2 meter length ranging rod, it will not be seen to you at all because pushers are there. So in such cases, we will be using a ranging rod of length 4 to 5 meters. Then coming to arrows, in the previous class I have shown this arrow. This is the shape of an arrow. It will have a sharp end at the bottom, and it is bent in round circular direction. Generally, this diameter is provided as 50 mm diameter, and normally thickness of this rod varies from 3 to 5 millimeters. 3 to 5 millimeters, and height of this arrow will be 20 centimeters or 200 millimeters. So, we are going to drive this into the ground. It also has sharp edge. We can drive it inside the ground to represent a point in our survey. So, this particular thing what we use is called as arrow. Then blood text. See, generally when you are working with your survey project, you will be closing your survey work at the end of the day, and tomorrow you want to continue the work. So at least 2 points should be there on the ground for next day's continuation work. Therefore, what we do is at the end of the day, we are going to drive 1 or 2 or 3 pegs into the ground. And next day after coming, we are going to establish that point and we will continue our work. So, these blood pegs, they will be generally, this particular shape, again, this also will have sharp edge. Then coming to plaster slabs and whites. See, this is also one of the instrument which is used in case of survey, particularly for identifying points which are more than 500 meters. Your visibility is not possible to trace out a ranging node held. Therefore, under such cases, we are going to use this plaster slab. It will have again a sharp edge to drive inside the ground and a board will be there, which is of 30 by 50 centimeter. This dimension is 30 centimeter and this dimension is 50. So, you can use this particular plaster slabs for recognizing the points in the ground. When the points to be laid are very far from each other. So, we are going to make it.